Okay, I have a couple minutes past 2 p.m. here in Tucson, Arizona, so we'll go ahead and get started. Thank you all for attending what is going to be the last session of this semester. My name is Jeffrey Gillen, and you have tuned in the final episode of NextGen Geospatial. And for the last session, we are going to cover SpatialTemporal Asset Catalogs, or STAC for short. So I'm kind of sad to see the series come to an end, but like all things, they have to come to an end, and we have to move on to do other things. So thank you very much for sticking with us throughout this semester. You guys can see that. I'll start with home. Okay, looks like you already posted it. I appreciate that, Michele. Okay, like always, our course content is here on GitHub. Just scroll down through the calendar. Gosh, we've gone through a lot of things. We started out with Cyverse, Geospatial, did the session on Earth Engine, did 2 sessions on deep learning for image analysis. Then we got into cloud native. We talked about cloud optimized geotiffs, cloud optimized point clouds, showed you quickly how to do a reproducible pipeline using Docker Compose. That was one of my favorite ones. Last week, we did geospatial data APIs with imagery from Planet. And the last session is SpatialTemporal Asset Catalogs. So go ahead and click into the material and get started. So what are SpatialTemporal Asset Catalogs, or STAC for short? Well, I would say STAC is it's a specification, you could call that, or a protocol. And it was designed to establish kind of a standard or a unified language about how we talk about and describe geospatial data. And the idea is that if we all kind of describe and talk about geospatial data the same way, it makes it easier for everyone around the world via the web to discover and share data amongst ourselves. So STAC uses JSON and geojson files to describe geospatial assets. So when I use the term describe, you could think of this as metadata, right? STAC is using JSON files and geojson metadata to describe geospatial assets. And those assets could be almost anything. They could be rasters, they could be imagery, remotely sensed imagery. They could be vector, like a point line or a polygon. It could be a point cloud. It could be a data cube. It could be any kind of geographic or geospatial data we can describe using the STAC protocol. And so STAC has been developed kind of really in the last, 3, 4, 5 years, something like that. I'm not sure exactly when it got started, but it's been kind of this open collaborative effort across many players in the geospatial community with the goal of kind of standardizing the way that we are describing and sharing geospatial data across the world. Some of those people include folks you might have heard of, like NASA and the ESA, USGS, Earth Engine, Open Topography, Maxar, Planet, Radiant Earth, and Microsoft have all kind of jumped on this STAC protocol for describing geospatial data. So what the concept essentially is that no matter where your geospatial data is, it could be on a server in Kansas, it could be on a server in Western Europe, it doesn't matter where the data is. What makes it all kind of, what we're trying to do is create one giant open source catalog of open data across the world. And if we all use the same kind of protocol, and that's the STAC protocol, the data can be anywhere in the world. But if we all describe our data using STAC, so here's my little conceptual diagram here. The clouds indicate some kind of cloud server somewhere. So we could have a cloud server with some geospatial data here, some of it's here, some of it's here. These can be in completely far-flung places in the world. But if we all use the same kind of metadata template i.e. STAC, then we can all bring those together to a centralized location. And those centralized locations are websites, essentially. There's a few different websites. One is stackindex.org. Another one is STAC Browser, which we're going to show here in a minute. And then I think also STAC Spec is another place. So yeah, we'll just continue here. We'll start with what the browser is. So to give you an idea what this looks like, let's just click on this STAC browser. This is created by a company called Radiant Earth. All right, so here's the STAC browser. This is an open source project. There's something in the chat. Weird chirp tone.
Yeah, it might be you clicking.
Is that me doing that? Is that
Maybe.
it, David? Yeah, I tend to make noises. Okay, so here's the STAC browser. This is an open source project. Yep, it seems to have gone away. Okay, might have been me. So this thing is open. It's on GitHub. This website is, I believe, served on GitHub. Yep, github.io. And this is kind of a centralized place to find like where all these other STAC catalogs exist. And so you can type in a URL if you happen to know the address of an existing STAC catalog. I don't have any off the top of my head. So you can also just kind of look through a list of different STAC catalogs. And let's go. Where do I want to go? I was going to find planetary computer. All right, let's check this out. Tyler, you were jumping the gun. Yes, of course. Yes, there are different ways to search STAC programmatically. That's we will be doing actually an exercise on that. Just browsing it through the browser is just kind of a way to understand kind of conceptually what it is. And then yes, of course, there's programmatic ways to make this more efficient. Okay, so I'm at the Microsoft Planetary Computer STAC. And what this is a catalog that Microsoft has taken all of the geospatial products that they have kind of aggregated for their planetary computer, and they have applied the STAC protocol or the STAC metadata, JSON and geojson files onto all of their data products. And then this browser has been written, and so it will crawl over these JSON and geojson files and then render them into this kind of nice display. And so, yeah, you can just kind of manually look through it and see if there's any data products of interest to you. And let's just find something to click on here. Let's go with sea surface temperature. I don't know what this data product is exactly. I've never actually clicked on it, but let's check it out. Okay, so once you click into a catalog, we are now looking at, I believe these are called collections. And so we have a collection page, and that gives you a bit more information about what these things are. We got a nice kind of description about what the data products are, and hopefully they tell you like, yep, here we go, the license, we got the temporal extent, what's available. If we want to drill down even further, we can go to items, and let's click on an item. Okay, and so in this case, an item is it like one specific date?
Push in the chat, Jeff.
Yep, we'll get there as well. So we submit requests section, I think could be included in a STAC archive. Yes, of course. So Tyler is asking the questions here. He's asking is like, can we get our data or someone else's data included in the STAC community? I believe so. Yeah, you can send the kind of the organizers, contact them, and you can get your stuff, whatever geospatial data you might be describing with STAC. You can get it implemented in the STAC browser or the Stack index, essentially becomes a list of all the different stacks that exist out in the world. Absolutely. This is very much kind of an open source community type of effort. Okay, so we were back on an item. And I'm not sure what item means in this case. This is a specific AVHRR. So this is a satellite imagery product. Looks like for a specific date. All right. And then we finally get to asset. Asset is the actual geospatial data. And that could be, in this case, it's a cloud optimized geotiff, right? Or we could get sea ice concentration as a cloud optimized geotiff. So it looks like most of what they're doing are raster geotiffs. Very cool. And does it actually give us the URL to actually get it? Yep, copy URL. So you can download it or get the URL and you can stream the cogs directly into where you would like them, into Jupyter Notebook or some other analysis area. So that's just kind of one example. Let me get back out. So yeah, this is not a centralized effort. So this is everyone kind of taking the STAC protocol, which is, you could call it metadata, essentially describing their geospatial data, doing it in a JSON and geojson format that can then be, that is standardized. And so then we have a standard way to view through the STAC browser, or we could do it programmatically. Okay, let's go down to static versus dynamic catalogs. All right, I'll show you a few different other things here. So the Microsoft Planetary Computer is a STAC API, which is what we call a dynamic catalog. So in this case, Microsoft is actually serving an API from their hardware that allows us, the users, to go into their API, find out what's there, get things, and also do spatial and temporal filters. So if I did this little search function here, I could go into calendars, or temporal extent or spatial extent. Let's say somewhere over North America. Well, I think this is about options, so we'll try that. Let's see if that leads to anything. Request failed. Okay, I'm not sure why it's failing exactly, but that's okay. Let's see if I have to have a temporal extent to do it. Yep, I'm not really sure. Anyway, if we have a comment. So this catalog page, sending inquiries to the Microsoft STAC API to display the data that you're requesting. That is correct, Derek. Yes, so this is a dynamic STAC catalog, i.e. it's an API. And so I can send a request and I say, based on this spatial and temporal filter, send me back results that exist in your catalog. And to do that, you have to have, the person has to have an API. So there is, let's go back to very beginning here. Let's just get up to the very top. Right, to go here to find. All right. You look on for each one of these items here. So these are all individual STAC catalogs that individual people have contributed around the world. And on the right, it'll say catalog or API. And an API is what we just talked about. So this is a dynamic catalog, but they have to be serving an API, which takes a little bit more savvy. If it's called a catalog, that means it's just a flat files, JSON and geojson files. You can browse through them just the same, but the filtering, the dynamic filtering of spatial and temporal aspects of the data, you're not going to be able to do. And so the APIs are a lot more powerful, but they're harder to pull off. You don't have the savvy or the technical skills to be serving an API out constantly. And a catalog is a much easier way to do it. But then your users who are going through your data, then they have less tools to search through your stuff to find things of interest to them. Right, so we talked about static and dynamic catalogs. And let's talk a little bit about the catalog structure. So like I said, it's all just JSON and geojson files. All right, so there's nothing really fancy about it, but they are organized in a standard way. And they include something called catalogs, collections, items, and assets. And they're nested. And so you can have a catalog, and then that can have a collection. And then within the collection, there are items. And then each item can have multiple assets. I'm not going to get too into the weeds with that. But just know that the catalog and the collections are JSON files. The items usually are a GeoJSON because they are usually going to include some kind of geographic coordinate. It could be an example of an item can be a Landsat scene, for a specific time and a specific row, so that could be an item. And then the asset is the actual data behind the item. And that is usually it's going to be sitting in cloud storage somewhere, and that could be like any kind of geographic data. It could be geotips, point clouds, ZARs, anything. Okay, I've got a question from David. If you had the compute to do so, does anything in the STAC ecosystem allow you to filter, query a static catalog to get the same output? Not that I know of, David. My limited knowledge is that to crawl through a STAC catalog and find things of interest, with a spatial and temporal filter, it needs to be an API. I think there could be ways around that that I'm not aware of. That would be, something worth exploring. Okay, thanks. No problem. Okay, so stat catalogs are just JSON, nested JSON and GeoJSON files. Let's see, so when we say JSON, it looks like this stuff here. So it's just a, very kind of lightweight JSON files that just kind of, describe different aspects of the geospatial data you're trying to describe. They have specific tags and specific kind of categories that can capture any kind of geospatial data, but it's all about trying to create this metadata in a standard way. And so it can be browsed in a standard way, and then also the APIs can be crawled in a standard way. If everyone in the world is all describing their data the same way and has the exact same API protocol, then you've essentially made one giant catalog. It's a distributed catalog. The catalog is not all in one place. It can be many places across the world. But the protocol and the way you program, the way you write code to get it can be identical. So that's the idea, is like, instead of trying to reinvent new catalogs and new APIs every time someone wants to put geospatial data on the web, let's all do it in a similar standard way. So that's the idea behind STAC. I don't want to go too deep into all the little weeds and details. So for the exercise, we are going to actually programmatically crawl a STAC API, and we're going to do that in Google Colab. So if you're able to follow along with me, that would be great. I'm going to open this up right here. Okay, what am I looking at? This is a Jupyter notebook, which is an environment to run Python code, and it's being hosted on in Google Colab, which is Google Cloud Computing. And so yeah, it's I've used these for most of my classes, and they're just a great way to kind of share, educate, help people understand topics. But they are this is we are using a Google product. So like almost everything Google does, it's kind of a freemium business model. So they'll give you a little bit of compute, but if you want something more for an actual research project or actual production, you're going to have to pay them or find a different source. So first thing I'm going to do is just connect to my resources. We don't need anything fancy. This is a pretty short little notebook, just whatever their kind of minimum CPU allocation is. All right, so what are we going to do in this? Well, we are going to tap into the STAC API served by Microsoft Planetary Computer. We're going to apply some spatial and temporal filters for it, find some imagery, some satellite imagery that we like, download it and bring it into our Python environment. So that's the idea. Last week we did cover geospatial data APIs. So this is also an API. It just happens to be a STAC API. All right, so I'll just go ahead and start clicking the code snippets. And if you're following along, please do the same. If you hit any snags, please let me know. All right, first thing we're gonna do is just install the required Python libraries to do this. We are using something called the PyStack client, which is, pretty self-explanatory. That is how you use, how you tap into STAC APIs via Python. And then we also have to use install the planetary computer one. That gives us kind of access to going through planetary computer data. All right, so we've installed. Let's import or bring in the libraries into our environment. Okay, and this one is simply, we're going to tap into the STAC API from Planetary Computer. And so this is the address of the API that we're going to tap into. And you should be able to find that. Oh my gosh, go away, Zoom. Zoom is just so in the way so much time. All right, so how did I find that API address? Stack Browser is kind of often my starting point. So did I miss it already? Here we go. Microsoft Planetary Computer. And so you can click this button here. Oh, is that it? What do I want here? Source, here we go. So this is the URL or the web address where Microsoft Planetary Computer is serving out their API. So I'll go back to, oh, hi, Malika. All right, so that's how I got this address. So I'm just going to run this code snippet and we are going to, basically tap into the Microsoft Planetary Computer API. So I actually used to give a session on Microsoft Planetary Computer, but it appears that Microsoft has sort of pulled the plug on that project. Their data is still available. They have a really nice data catalog that you can use. That's just kind of free and open source. But the Planetary Computer, in terms of giving you access to using Microsoft Cloud resources, I think they have discontinued that. Okay, so the next bit of code is just about seeing what kind of collections are in this root catalog here. And so we're just going to start like rifling through the different catalogs and collections and items that exist in this API. This is going to print the number of total collections that they have, so 124. So if I were back here in the browser, yep, see, 124. So that should match. So we are looking at two different ways to do the exact same thing. One is the browser, and this one is doing it programmatically with Python, but it should contain the same information. All right, this little code block here is gonna, tell me the name and ID of every one of their collections. So they have a lot of interesting stuff. I'm not sure, like, what prompted Microsoft to aggregate or put into their data catalog. But I'm glad they did. It's just like another great location to find lots of good stuff. So thank you, Microsoft, for aggregating it and making it available to us. So that's 124 different collections that we could go through if we like. Okay, so I'm going to create a spatial and temporal filter to go find something of interest of mine. All right, Tyler, let's see. So if you wanted to use data hosted on Earth Engine, but not their processing power, you could access their datasets via their OpenEO STAC archive. Is that right? Let's see. Does Earth Engine index everything in STAC, I guess is the question. Don't know. How do I get back out of here? Yeah, well, let me get back. All right, so we'll have to check that out later. I'm not sure. I know Earth Engine puts some stuff in STAC. I don't know if they like index everything. Um, there are other catalogs, for doing that, like the awesome Earth Engine catalog from Sam Priya Roy. It's probably a better way to do that, but I'll have to look when we're done here if Earth Engine indexes everything in STAC. Not sure. Okay, so here we're going to create a spatial and temporal filter to find things that are specific interest to me. So I'm just going to go ahead and hit run. And so I'm looking for data that's within December of 2020. And I'm specifically interested in this this box here. So this is we're up in the Pacific Northwest of the United States. Is what this latitude and longitude bounding box is. Okay, and I am interested in looking for it in a collection of Landsat. So in Planetary Computer Dataset, they actually have extensive catalogs of Landsat, believe it or not. So that's where I'm going to go searching for it. Okay, this next one, it's going to show me all the items that I think match my filter. Okay, so based on my filter, this is what it came up with. This is what it's returning. So we have Landsat 8, we have Landsat 7. Landsat 7 still orbits. Wow. Okay, let's keep rolling through here. How many total items are there? I'm not sure. It tells me. Oh, 8. Okay, we found 8 total items. Great. Now what I want to do is add another filter, only I'm very interested in the item, the Landsat scene with the lowest cloud cover. And so I can add in a cloud cover filter. Yep, so I'll just hit play on that one. Okay, so it has identified the exact scene that I need based on my filters. And now it's going to show me the list of assets. So now we got to item. Now, an item is usually a specific Landsat scene, and then the assets are like the actual data. And so for Landsat, the assets could be, it could be just like raw, raw multispectral data. It could be surface reflectance. It could be radiance, all the different kind of imagery products you can create. That's what the assets would be. Dan says Landsat 7 is still flying, but the primary mission ended in 2022. Yeah, okay. I just know people kind of abandoned Landsat 7 a long time ago because of the striping with the scanner. All right, so let's see all the different assets we can get for that one Landsat scene. Wow. Oh my gosh, there's a lot of different things we can do. Get all of just all the different individual bands, surface temperature, and okay. This is just to take what we got and put it into a dictionary. Aha. All right, so that is, I believe, what we are interested in. That is the URL for where it actually is located, I believe. No, that's a thumbnail. Sorry, rendered preview, that's a thumbnail. So let's display this rendered preview. Okay, and so here is the Landsat scene that we could download or stream. And so this is just a preview. It's like a low resolution thumbnail just so we can view, see what it is we're interested in getting. Here we are, we're showing the Olympic Mountains in Washington State. And then I'm interested in the blue band. I mean, I'm not sure what I do just with the blue band, but for demonstration purposes, let's just get the API endpoint for the blue band. And so it should tell me then what the actual URL is to actually get the data, which should be in Microsoft Azure storage in some way. Okay, yeah, it's in their blob. It's in Landsat EU West. So apparently this data is in the European Union West somewhere in their blob storage. So that's where it is. Excellent. Okay, where did the thumbnail come from? Does the API include a thumbnail server? The thumbnail must just be a part of the assets here. Do you see like a thumbnail in terms of an asset? I don't. I guess I don't exactly know. It must just be, maybe this is it. Oh, thank you, Malika. Yep, that's probably it. Tile JSON with default rendering rendered preview. Yep. So yeah, so that the thumbnail is just there in case you want to look at it in a quick and dirty way. All right, there's the thumbnail. I want the blue band. It tells me where the blue band is located in the world. That's where it's at, somewhere in Western Europe. All right, and now let's actually go and get it. Remember, am I downloading it or am I streaming it? Okay, let's just hit there. Okay. This is actually just going to reach out to that data product and get some information about it. So I'm not grabbing it yet. I'm just going to get some information about it. Status code 200, that means it's good to go. We would like a 200. It's an image, it's a TIFF, and it's 75 megabytes in size. I like to usually get a little bit of info about the image before I click, download or get, because I never know how big some of these files can be. All right, and this next one is going to be to pull this asset from, I guess, Western Europe, and it's a COG, it's a cloud optimized GeoTIFF. And I'm just going to bring it here into my notebook. I can't remember if this is actually this is going to be, let's just hit go. I don't think we're downloading. I think we're just bringing it into memory. Not sure. Let's see. Okay, and there's the blue band. I just had it visualized real quick. And yeah, pip install ReoX array, href, squeeze. Yep, okay. So we did not download it. We basically essentially just streamed it over here into our Python environment, but now I have it and I can do anything I want with it. I displayed it, and that's as far as we're going to go with the Jupyter notebook today. But then, yeah, once you have it, then do anything you want with it. And you could write the Python to download it if you want. But since we've been doing cloud native stuff, I thought I'd just kind of stream it over. And so it should just be in memory. don't think I downloaded it. Otherwise, it would be sitting here somewhere. Okay, so I hope that that notebook was clear and simple. What did we do? Well, we started here, like in the browser. We found data of interest to us, and then you can go to your Python and actually programmatically write it to go through the API, find something of interest to you, and bring it over to your computing environment. And let's go back to the main catalog. And so a lot of the data here, you can do it the same way, I believe. At least that's the idea, is this is all done in a standard way. So if it says API, you should be able to do essentially what I did, for all these other different stat catalogs. If it is catalog driven, or just like a flat catalog, you probably then have to go through and browse things, I believe, and then click download or stream through it. Let's see. Derek says that this was a static catalog. Would there been no way to download just this tile? I guess I'm confused whether the subsetting is provided by STAC or COG. In this case, it would be provided by the COG. The STAC is just describing what the data is and where it's located. But if you want to actually get the data, we are able to get it because it is a COG sitting in blob cloud storage somewhere in Western Europe, and we are streaming it over into our Python environment. So the two things are separate, if that makes sense, Derek. STAC is just metadata, and that helps us find this COG, but then the COG can come to us because it's in cloud, and it's a COG. Does that make sense? Okay. Okay. So I hope some of that makes sense. I want to keep today's lesson a little short, just kind of a quick exposure or introduction to spatial temporal asset catalogs. It's kind of an interesting kind of open source, grassroots kind of community thing that a lot of people in the geospatial world are starting to adopt. If you are a producer of geospatial data, you could consider looking into this kind of ecosystem, and perhaps describing your geospatial data in STAC protocol. If you're interested in doing so, we have a few resources here about like how you can actually make the stack. I have some Python code to actually do so. So please explore some of these resources. The easiest way is to create a flat a flat catalog, like a static catalog, sorry. And then you can contact the people at the index or the browser. I know they have specific like contact us to get your data listed on our on our index. And so that's a way for kind of everyone in the world to see and then be able to find and get your data in a kind of a standardized way. Okay, and I will leave it at that. Stop the sharing. Do I have any other questions or comments or anything? This is the last session we're doing. And so thank you all very much for being such a great audience and showing up week after week. It fills me with confidence that some people find some of this stuff interesting. So thank you very much for attending. And I can I can take any questions, or if anyone has anything else geospatial related. Thank you, Malika.
Maybe can I just ask a question
Sure.
verbally? This is
Yeah, yeah.
Derek. Hey, and thanks,
Hey,
Jeff. This is awesome.
or Eric, sorry.
Yeah, yeah. I guess so. I'm trying to still wrap my head around the difference between a static catalog and an API, and um, everything in your notebook. Well, some of that was required it to be an API. Is that right? But
I believe so. That is my current understanding, is that
Okay.
to do the spatial filters like that and to reach in programmatically, I think it has to be an API. I think. I
Okay.
could be wrong. Like everything in this workshop series, I'm kind of teaching you the status of my knowledge, which might not be complete.
Okay. Yeah, totally.
But that's what I currently understand. And so yeah, serving up your own API is definitely a higher bar in terms of
mm,
making your data available. Tyson and I have done it. It's not impossible, of course, but it's so much easier to just to create JSON and GeoJSON files and put them on a web server. So
mhm.
that is a lot easier.
And it seems like maybe your notebook could be modified to be not quite as like have quite as the same functionality, but still like as long as you know there is a layer like and that its extent includes your area of interest, maybe that's all you need for, even from a static catalog, and then you can just use the subsetting functionality of the cog to get the subset. Does that sound possibly right?
Say it again.
Like you could use a static catalog just to know the existence of a data set
Right.
that it
Okay.
and that includes your area of interest and maybe way beyond. Like maybe the file, the cog is actually like the entire North America. But because it's a cog, you can download just the subset of it that covers your AOI.
Yes, that's right. Yes.
Okay.
Yeah, you could be in the STAC browser and and browse through static catalogs, find something of interest because it should tell you what the items or the assets are and where they are and all that stuff. And then yeah, you could then use the endpoint for that cog to then into, in your Jupyter notebook to then pull in some little area of interest as a cog.
Okay.
Yes,
Sweet.
correct. But doing the
Cool.
filtering, the spatial temporal filtering with Python, I think that has to be an API, I believe.
Okay. Aha. All right. It's cool. Thank you.
Welcome. Okay, well then I will sign off and we'll see you in the future. Thanks, guys. And this will be this recording and all my recordings are up on the U of A Data Lab YouTube page if you want to revisit or share with your colleagues. So thank you guys for being such a great audience, and we'll see you next time.